Hey, Blue. Yeah, AoC is the advent of code. I was like, maybe I should do it, maybe not, but yeah, I thought that, okay, well, let's just do like the first one here. It's like a programming challenge thing that comes up every year, like, you know, in December. You're kind of opening the presents, you could say, like each task is available every day, so you get like first today is the first task available, but then you get like the next one next day. And so it was basically like a, you know, programming okay, let me show you here. Do I have this somewhere? Okay, I'm logged in. Let me bring this up. There we go. Here it is. Okay, I have no idea what this is gonna be. Yeah. So there's 12 days of puzzles each December. Okay, yeah, I think the previous ones were longer. So we'll get 12 days. Like the old song, 12 Days of Christmas, right? Alright, and then it's like it's making some sort of picture here. It almost looks like we're burrowing into the ground. Oh, passionate about AI, hiring engineers, developers, and more. Interesting. Okay, let's start here. Are we doing this in with Zig? Alright, let's see. Day 1, secret entrance. The elves have good news and bad news. The good news is that they discovered project management. A wiki page there. Okay, this is giving them the tools they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations need to be finished soon so that other critical tasks can start on time. Okay. The bad news is that they realize they have a different emergency. According to their resource planning, none of them have any time left to decorate the North Pole. Okay. To save Christmas, the elves need you to finish decorating the North Pole by December. Okay. Collect stars by solving puzzles. Okay. This is like the overall goal, I think. Because it's like collecting stars. That's the thing you do every time. So like each puzzle gives you like a star or something. Like in Super Mario 64. 2 puzzles will be made available on each day. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. You arrived at the secret entrance to the North Pole base ready to start decorating. Unfortunately, the password seems to have been changed, so you can't get in. Typical. Document taped to the wall helpfully explains. Due to new security protocols, the password is locked in the safe below. Please see the attached document for the new combination. The safe has a dial and with only 1 arrow on it. Around the dial are the numbers 0 to 99. Man, that's a lot. As you turn the dial, it makes a small click noise as it reaches each number. The attached document, your puzzle input, contains a secret of rotations, 1 per line, which tells you how to open the safe. A rotation starts with L or R, which indicates whether the rotation should be left towards lower numbers or to the right towards higher numbers. Okay, then the rotation has a distance value, which indicates how many clicks the dial should be rotated in the direction. Okay, so it's like L5 or okay, that yeah, L68. All right. So if the dial pointing at 11, the rotation R8 would cause the dial to point at 18. I mean, you could also just yeah, you could just take 11 plus 8. So it's kind of like the number line. Going right means plus, going left means 19. Except when it's 0, what would that be? Like we would wrap around, I guess. Because of the dial is a circle, turning dial left from 0 1 clicks makes it point at 99. Similarly, turning the dial right from 99 1 click makes the point at 0. So if the dial were pointing at 5, rotation of L10 would cause it to point at 95. Yes. Dial starts by pointing at 50. You could follow the instructions, but your recent required official North Pole Secret Entrance Security Training Seminar taught you that the safe is usually a decoy. The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. For example, suppose the attached document contained the following rotations. Following these rotations would cause the dial to move as follows. Yeah. Because the dial points to 0 a total of 3 times during this process, the password in this example is 3. Analyze the rotations stored in the document. What's the actual password to open it up? Okay. Get your input. Alright. So I think we have enough information here. What if I could just do like 1, so 1, and then we'll do like 1 input. Oops. Is that the whole thing? 4,500. It looks correct. Hey, penguin. Okay. So let's have like main. What the hell is this syntax? Or I mean, these colors. Whatever. I'm just gonna try running this. Okay, it works. Kind of like a script. All right, so let's open up the file. No, actually, it's gonna be standard working directory. Open file. One.input. And close it. Let's get the contents. It's gonna be read all. No. Read to end alloc. We need an alloc. Well, let's just actually let's make an arena. It's just funny that the first thing they have to do is create an allocator. This is gonna be for everything. All right. I mean, we could just do this actually. Let's make like utils. Just to make it faster to do everything later. Init. No. File. So that's the file path. We get a puzzle input. We need. Well, we don't actually need like an. Well, we need. I guess we need the GPA. Actually, we'll call this just puzzle. Yo, hilarious. Yes, it does. Okay, we'll make a function called load file name. Alright. So we got the GPA. We'll make an arena. And we don't need to do that. So we'll do arena and then GPA. There we go. We open the file, we close it, we read it with that's shadowing. Not sure. Max bytes. I don't know. What's 4,500 times 5? 20,000. Alright, let's do like, I don't know, 16 megabytes. Yeah, that's... Okay, the contents, put on self, try. There we go. All right, now we can read in. Now we can read in the file. And we don't have to make a allocator. All right. So input or puzzle. It's gonna be puzzle initialize, and then we load the file, which is one.input. Now, let's see if we got something. So let's do standard out. Actually, let's put standard out in puzzle so we don't have to deal with that. Alright, so now we can do like puzzle, standard out, print, or just write all puzzle contents. Actually, we could set this directly here. But this one is on the one. No, wait. There we go. All right. Okay, well, we can use it. We can reuse it for later puzzles. So now we have this puzzle thing, which we can load in whatever input we can use. We can use standard out to write whatever we need to write. All right. Now, okay. So basically, we had. I'm gonna make a. Well, we could try it on like lesser inputs as well, but I'm just gonna do, you know, whatever. Let's just do let's do a line iterator. Yocom, how's it going? Alright, and then we'll check, like, you know, if this is or we will grab out the number. Now, do we have some kind of parse? Yeah, there's parse int. Let's do like, I don't know, usize. And the buffer is going to be line 1. Yeah. So basically, this is what's going to happen here. Now, at the end of each one, we're going to check. Also, yeah, we need the sum. Or, yeah, let's just call it sum, or password, I guess. We start at 50. And here is like if password is 0, then we increase. No, wait. The password starts at 0, yeah. And then we have the dial starts at 50. Did day 1 in Wiwa, but probably try zig later. Oh, nice. Did it go well in Wiwa? Was it easy or hard? Let's see. If password is 0, we will increase. No, if dial is 0, we will increase password by 1. And at the end, we will say write or print password. No, that's not how you do it. There we go. Alright, the dial needs to be modified in some fashion. Well, the right one is pretty easy because it's just going to be like dial plus equals n. We can, yeah, because n is never going to be. We'll do like mod dial plus n 99. No, wait, it's 100, right? It could go up to 99, right? Went pretty well considering no experience with Wiwa. The problem itself wasn't too difficult. Wiwa definitely feels more confident APL to me. Yeah, I mean, it's more modern. And it looks cool. But Wiwa is, I mean, APL is not stack based, right? Or, I don't actually know. I've never done APL, but I just got a feeling it's more like, it's not stack based like Wiwa. No, wait, is Wiwa the stack based one, or is that something else? I don't remember. Mostly reading other people's solutions, understand how to read Wiwa, makes some obvious shortcuts. Alright, yeah, okay. APL is array, yeah. A Wiwa stack, yes. What was the other language called that was like also kind of the same, similar, but more like APL? It wasn't stack based. Man, I can't remember now. All right, and but the thing is here, like, because I mean, if we assume that, you could just assume that the size of this number that we get back is gonna be within the thing here. Like if we do add, this could be like an error because of wraparound. I guess maybe not, because dial is always very low and n is probably not going to be near the limit. I guess we'll just wing it, whatever. I guess if n is more than, okay, we can do this. If n is more than 100, we can just subtract 100, and now we're kind of guaranteed to not overflow here. No, not J. It had more letters, like 4 or 5 or 6 letters. It doesn't really leave it open for or it does leave it open for many, maybe. I don't remember what it was, but it was basically, I was looking at like Viva and this other language, and they kind of were similar, but the other language was also like array based, like APL, but a more modern one. Yeah, okay, so then, I mean, this would always be n, so we don't need to do that. And here, I guess it's kind of the same thing, like if n is more than 100, we can always like subtract 100, so that we keep within the limit, maybe? Is that even needed here? Dial. So basically it's gonna be like dial is equal to dial negative n. However, we also need the wraparound. Maybe we can use the built-in features here. We do a wraparound thing, and then we don't need to do this. So we do a wraparound, and then we'll check if dial is more than 100. We will subtract max int type of dial minus minus what? 100? Wait. I'm kind of looking at it like truncating the whole thing down to 100. So now we're removing trying to stack based, yeah, BQN, yes, BQN, that was it. Trying to stack based ones is called Raptor. Oh, I never heard of that. Sounds cool. This one, this is like a wrapping. It's like minus with wrapping behavior. Normally in Zig, if you do this, and so basically, okay, let me show you here. So basically, if let's say you have var x equals, so let's say this is this is an unsigned. Let's use this as an example. Let's say this is like 5. So this is an unsigned integer with 8 bits. So it's a byte, unsigned byte. So it can't be negative. And then you have another one which is 6. Okay. Normally, since unsigned integers can't represent negative numbers, if you take x minus y, this will be a runtime error because of I don't know, it's called overflow if it's below 0, I'm not sure, but there is, or underflow or whatever. It's an error because y is greater than x and the result cannot be negative, so that's an error. But in Zig there are also 2 operators that you can use that will change the behavior. So the built-in way is to throw an error basically if this happens, but if you do this, you do a wraparound. So basically, I guess this, I don't remember if this is like the native, you know, CPU way. You know, it's gonna wrap around. Well, there is like an overflow bit that basically you can look at, but it's gonna wrap around x. So it's gonna get like -1 or the maximum. So this here, z is gonna be like 255 or something like that. Right, because it wraps around, because the bits, because of how the calculation works when like doing that. And then there's this one as well, which is like this operator, which is kind of, I'm not sure what it's called, but it's also modifying the -1, the minus operator. Now this basically caps the value, so you can if you have something more, if this is larger, if y is larger than x, this will just cap out at the bottom here. Instead of being an error. And similarly the other way around, like if this were, if this was like near the end 250, 249 or something, or let's say 254, and then this is 2. Now you can also do the same with plus. So plus 254 plus 2 is 256, but that doesn't fit in a U8, so it will wrap around to 0. But then this will cap it at 255, the maximum value. Yeah, no problem. So this will kind of, you will, not only do you not get an error when doing this, you will be able to like determine the behavior, which is pretty cool. So here I'm actually like, because n could be larger than dial, I could wrap around. And then the idea was that I would like subtract the maximum int from dial, because it has to be like larger. Well, with this work here, this would be kind of interesting. Like we have the upper end sort of here that we remove. What would this be? Like let's say like n is the max, and then dial negative max negative 100, where dial is like max minus I don't know, 55. I'm not sure if n is gonna, if it's gonna wrap around more than once. Well, no, dial is, no, it's not max minus 55. Let's say it's like 32 minus 55. That's gonna be if in a mod 100 system, this is gonna be, no, let's make it easier here. Let's do like 10, 15. This is -5, but in a mod 100 system, this would be like 94. 0 is 100. So -1 would be 99. -2, 90. 8, negative 3, 97, negative 4, 96, negative 5, 95. Okay, so it's 95. And now, but it's also, so that's in mod 100 land, but it's also maximum -5 as well. No, is it? Well, yes, no, because 0 is counts. So it's like -1 is maximum, -2 is maximum, -1. So it's -4, I think. Yeah, I think. Okay. So what would we need to do? We would need to basically, we need to get this to 95. If we subtract M, we would be having an error. But if we subtract D minus M minus 100, this would be D, well, M minus 4 minus M minus 100, which would be M minus 4 minus M minus 100. 2M, no, it's not 2M, it's, wait, this doesn't make sense. No, that's just negative 104. No, wait, I'm doing it wrong. This is plus, no, wait. This should make it plus 100, right? My elementary math skills are failing me right now. So it's 100 minus 4, which is 96. So this should be 99. So plus 99, 95. So this should be 99. Okay, is this correct? Three arguments. Oh, it needs a base 10. Oh, you can be an error. Okay, let's do try. Use size and void. What? Oh, dial is that. $36. No! That was wrong. God damn it. Wait, did I do this right? This is that. Wait, if it's more than 100, yeah. No, more than or equal. Still 36. Wait. No. Okay, let's do this. Let's do like function solve, and we get a number out. And we get the, let's get the, yeah, let's just get the contents here. There we go. And then we'll spit out the password. All right. Solve puzzle contents. Okay, it should still be 36. I guess this is a thing there. Alright. Now let's make a test. So let's make a something thing here. This will be like I don't know. So as long as it's going to 0, let's do like L25, L25. That should put it at 0, right? And R1, R43, L44, right? 60, 70, whatever. Now, okay, so that should. And then we do solve for this, and then we do expect this. I'm gonna expect this to be 1, 2, yeah, 2. Now we need to do test. Expected 2 found 0? What? Okay, let's just do some logging here. N is N. This is a character. It's gonna be line 0. And the dial. What the hell? The dial didn't change for like... It only changes for right. Oh, what the hell? Okay. Alright. Integer overflow. Okay, we got integer overflow. How? It should be more than 100. This should never be like... Okay, let's add in the mod here as well. 95. This is kind of weird to me. Well, I guess I didn't think about any kind of edge case that would cause this to be over 100. Okay, what do we say? 95. Well, that's not right either. Okay, let's add 100, 150. Now we should be, let's do like, because we're going from 0 to 50, then we go to negative 150, and then back again 0. That should cancel it out. Still passes. No, but now it should be 3. Yeah, so 1, no, 50. No, left, then it's 0. Right 44, left 44, now it's 2. 0 again, so that's 2. Right 50. So from 0 to 50, and then negative 50, and then 50, and then 0 again. So it should be 3. So this, what? And now it doesn't work because it skips that. Do you know Sandbox engine is open source now, which is built upon Valve's Source 2 engine. Sandbox is a successor of Gmod. I didn't know that. That's cool. Interesting. It's probably like C++ or something, right? Okay. I wish I could get this. Well, let's just do this up here instead. And we'll run it. And this is 2, of course. And then we'll bring back this print that I took away. N T dial. Let's do P for password maybe. N90. Dial is dial password. Too few arguments. Oh, so we get N, type, dial. Oh, the first one. Ugh. Okay. Dials there, then that goes to 0, then that increases, then we go to 0, that increases. Okay. Here, 150 left, it goes to 50. That's... Okay, there might be a one-off here. Let's just try changing this to 100. I might have been wrong there. No, it still says 2. And this didn't change. Did I save it? God damn it. How can there be no difference? Maybe it's the mod that does it. Like if we remove this mod, it does work for some reason. Wait, what the hell? How can 50? Okay, so we are at 50. Then we go right 50. This goes to 16. What? But if we remove the mod from this part, it goes to 0. Okay, that does not make any sense to me. We're not even in the... We're not even on that place. No, okay, if we mod here, that's gonna mess it up because when we wrap around, that's gonna be messed up. Yeah. So we do it... Yeah, no, I think it's because we're wrapping around, so it's messing up the calculations there. Let's try running and see where it becomes an issue. $624 to the right. Then that becomes 0, and then 595 to the left. Okay, I see what could happen here. 595. So when we go left, this wraps around. I was always thinking that N is like always gonna be, but really N should probably... N also lives in mod 100 land, so we could mod N by 100 as well. Okay, there we go. 1145. There we go. Oh, there's a part 2. Wait. Okay, so part 2. You're sure that's the right password, but the door won't open. You knock, but nobody answers. You build a snowman while you think. As you're rolling the snowballs for your snowman, you find another security document that must have fallen into the snow. Due to newer security protocols, please use password method. This until further notice. You remember from the training seminar that this means you're actually supposed to count the number of times any click causes the dial to point at 0, regardless of whether it happens during rotation or at the end of one. What? Following the same rotation as the above example, the dial points at 0 a few extra times during its rotations. The dial starts pointing at 50, dials rotate 68. Oh, I see. So it passes 0. So we need to count when it passes as well. Well, it does it once. Yeah, it always does it once, right? Or wait, in this example, the dial points at 0 3 times at the end of a rotation, plus 3 times more during a rotation. So in this example, new password will be 6. Okay, so we're counting both when it lands at 0 and when it passes 0. Okay. Okay, be careful. If the dial pointing at 50, the single rotation like our 1000 would cause the dial to point 10 times. Oh, I see. What is the password? Right, it's the same input. The input hasn't changed. Okay. Alright, interesting. So, I mean, we could just take, in terms of, couldn't we just take, so first you could take like how many times would n pass 100? Like you could do like I guess I'm not sure what's called, like n div. This would be like n divided by 100. Let's do like floor n 100. So this would give us how many times n would naturally pass 100, no matter what dial actually is. And then we can do add if dial plus n is more than or equal to 100, then we also pass it once more. I think if dial is like 0 and n is a 100, okay, then this counts twice, so that doesn't work. I guess we need to check if dial is 0. If dial is 0 and or not equal to 0. If it's not equal to 0 and then this is more than 100, then we get 1 extra. Otherwise we get nothing extra. Not the most elegant solution here, but I don't know. I tend to do this stuff when it comes to these kind of puzzles. It's like, I don't know, this just doesn't really come to me like this a kind of elegant solution or anything right now. Alright, so because yeah, so this is like if n is 100, this would give us 1. If it's 50, it will give us 0. If it's 150, it will give us 1. If it's 200, it will give us 2, and so on. And then also if dial plus n, so if n is like 99, for example, and dial is 1, then this will give us 1 extra, because n is 99, so that doesn't count over here. But if dial plus n is over 100 or equal to 100, then we get 1 extra. But if dial is 0, then technically n could be 100, so we have to cover that case as well. Okay, so now we've got n div there, so that's the extra we need to add to our password, plus equals to that. All right, and then this basically the same thing here. So yeah, you could just straight up check before we do the mod, preferably. We just check how many rotations. Oh, we need to do it before the modification of n here as well. So before any modifications, we look at n, how many times does it wrap around 100? Now, what about this here? So now dial is supposed to be, if it's 99, and then if dial negative n, so if this is not 99, or maybe it's 0 actually. Maybe it still is 0 here. Yeah. And then this gets negative, yeah, because if this is negative 100, then it goes back to 0, right? If this wraps around, it will be more than 100. I mean, I guess it will be more than 0. No, wait, not more than 0. More than 100, yeah. Because dial is between 0 and 100 or 99. This wraps around. If this is more than 100, then we wrapped around. And we get this, I think. Okay. Will that work? So let's just do like extra. Extra is a U size. Now let's just do password plus equals to that. And then extra. Seven, 4, 7, 6. No, it's not correct. Okay. God damn it. If you're 0 and number steps 100, you still hit 0 once. Yeah, so the idea is here that n is how many clicks we do. Be careful, minus %, it wraps around the integer. Yeah, that's the whole point here. I'm trying to use that fact in order to check if it's actually wrapping around. Like it's kind of like a gimmick in the code here. So basically, well, the idea is here, like, we check how many times does 100 fit in here. That should be added here, because then those would automatically give us, you know, 1 full rotation and 1 extra password hit there. But we also have 1 extra that we could get if dial plus n is more than or equal to 100. because then it wraps around, right? But only if this is not equal to 0, because if it's 0, then technically n could be 100 exactly, and this exactly 0. And then we will get a double count from this and this. So we have to check if it's not equal to 0 there. So I think this is pretty good. But this one is more iffy here. I still think this... No, wait. Shouldn't this be like... No, it should be 0, not equal to 0, I think. Because if this is 0 and this is 100, we get a double count there. No, wait, this is the other way around. If this is like 0, then anything would give us an extra. I guess we just check if n is more than dial. Instead of trying to do this weird thing. And wait, no. This is break my right. If dial is not equal to 0, because then technically n, like if n is 100, it double counts. Okay, we could do this actually. We could calculate the extra after we've modded n. Maybe. Let's just mod n here as well. Instead of this. And then we can do this. And then it's like if n, if okay, what if n is exactly 100? Then this would give us 1. And then this would give us like 1 extra here. Except if dial is 0, then it shouldn't give us an extra. That should just give us 1. Yes. Okay. Here I don't think we need to mod it. I think I'm doing it for safety over here. Then what if we do this here? N just needs to be more than dial in order to wrap it around. However, we're checking it after the mod. What was it? 7725. God damn it. Oh wait, shouldn't it be like It should be equal, yeah. Except, no. Yes, except if dial is 0. What do we get now? 7706? It's like chaos theory. Almost. God damn it. What? Let's see. We're at 29. Left 38 gives us 25. That doesn't sound correct. No, it has to be it has to be left 4 then 25. Left 38 then we get 87. Yeah, this should be correct, and that does give us an increase there. Hey, Two-Step. Welcome back. How's it going? Advent of Code, yeah. The scripting language is doing pretty good. Are you able to solve AoC problems with? No. Well, I mean, maybe. I mean, I could use Bash as an extension, or another programming language as an extension of the language by using their you know, if we do like I forgot how to do this. Import, wait, no, import read file sync from file system. Fail to parse script. What? Expect this. There we go. We can use this. You can use another programming language to do it. Why am I not getting like LSP here? There we go. Eval ESM cannot print. We could do it like this. All right. Excuse me. Man, what is going on? I hate it when you get stumped on these because you just feel so stupid. Especially, it's the first one. Well. Does it get like double counted? Let's try the Let's try the test here again. Seven. So here we're at 0. Go right 50, get there. This goes left 150. It goes up by 3. That doesn't make sense. It should pass once and I go back to 0. So that should be like 6, not 7. So we're double counting over 100 probably. So dial is 50, N is 150, which is above. No, it's actually 50. Because we're modding it. Wait, isn't that correct then? Because it first passes 0 and then you got 100 left and it goes back to... No, wait, that's not correct. No, wait, that is correct. It goes back to 0 again. So that is correct. This is 2 extra and then back to 0. No, wait. Hang on. We start at 50 here. Right. We go left 25, we're at 25. We go left 25, we're at 0. We go right 1, we're at 1. Also, this goes to 2. That's not correct. Left 25 goes to 0. That increases by 2. This should be 0. How can it increase by 2? Oh, because of this as well. No problem. Looks like you're doing proper math solution. Yeah, well. My solution was just brute force part 2, so okay. Yeah, that happens sometimes. It just feels like you get stumped sometimes, but okay, well, if this is 0, then it should be a case in here where it goes to 0 and we count this anyway. So really, I think we get rid of that. Okay, now it doesn't double count this. And then, so we're at 0, we go right 1, so we're at 1. We go right 43, we're at 44. We go left 44, now we're at 0 again. Now we go right 50, we're at 50. We go left 150, so that should count 1 for the 100 and 1 to go back to 0 with the 50. No, we're not going back to... Yes, we are going back to 0 with the 50. So 0 and then we turn right again, 50. But then we should end up at 0 again. So we should be at 5 at this point. Right? No, because we're turning from 50 to... Man. We're at 0, right 50. Left 150 should be back to 0, right? And then right 50 we should go to right to 50. Yeah, this is correct. I'm pretty sure. However, the real thing was not correct when we did this one. 171.45. Wait, did I try that? I don't know. Let's try it again. 70. That's significantly less though. 71.45. That's not correct. No. Okay. Okay. 92, we go left. 39, we go left again, we go right back. We go left, we go left, we go right, we go left. We go right 7, okay. Let's see, over here. Do we have anywhere where it's like a lot? Here's 2. Wait, this doesn't look like a 2. 36 and then right. Okay, we're double counting here. We're double counting. Okay, so maybe this should be like over 99. Wait. No, should it be like 101? Or over 99? Wait. So 1 plus 99 is 100. It should be over 100, I think, because then we need to calculate it again, otherwise we double count. 6561. God damn it. Okay, that's still correct. 6561. 6561. 6561. Come on. 6561. God damn, I have to wait. 2 minutes. It's interesting though, like small errors like that, double counting this adds up in the end. Now this is 4. Can do another test. Puzzle 2. Let's do like 1,000. So this should be like so first 0, then 1,000. That's like 100. No wait, 10. And then right left, that's 0 again, so that's 1, 11, 12, 13, 14. Now we got 15. So 25, 0, still 0. We add. Okay, let's do this test then. Let's do 25, 25, then just write 100. This should be like, this should only be 2. But we got 3. So this is also wrong here. What if this is the only thing? Okay, 1 is correct. 1 is correct. But then we do like left 50. That should be go back down to 0, so that should be 1. And then 100, that should be only 1, so this should be 2. But that also fails. It's 3. So there's still some issues here. So it's when we just do this. Does it work for both of them? Does left also do that? Now we would expect this to be 3, but it's actually going to be like something else. 5. So it double counts if you just have 100. 1, 2, 3. This should be 3, but it's 5. So it double counts just the hundreds. So first we do this. So this is correct. This should be the only thing we do. And then n divided by, or mod, this should be 0. And here we're checking. This should also be 0, right? I think I know the issue answer, but I just trying to figure out how to logistically do this. So basically here, I think what we need to do, we need to break out if dial is already 0. We need to do just continue and not do this. I mean, you could do like was 0. If was 0 and, well, if it's not, if it wasn't 0, yeah, we're double counting the things. There we go. 6561. We still got the same answer. That's funny. So they didn't have any. That was just a multiple of 100. Okay. Well, that's surprising, but okay, that's an edge case that we needed, that we didn't need to take care of. Okay. 6561. Oh my god. I had the thing up all the time, but let's try this now. Hey, there we go. Okay, I'll show you what I did there basically. Well, we didn't need to do this, but this basically is like if the number, like L or R and then the number, if the number was actually a multiple of 100, then that also caused an issue. So we had to do this was 0. But what was it? Yeah, we just got rid of the double positives here. So this would be positive if there was something with that thing. Okay, anyway, yeah, that's it. Great. Alright, should we do some runic maybe? Actually, I can solve this in runic. There you go. Solved in runic. First, world first. Why is it so slow? Alright. Cool. Thank you for that. Should we do some runic? Maybe arithmetic. That seems like a super easy thing to add. N is unsigned in your solution using plus wrapping. Yeah. Yeah. I tried to use the wrapping thing because I thought I would be super tricky here. I used the wrapping for negative, so we can detect if it goes below 0 basically with an unsigned integer. But you know, you can also do your solution by using a signed integer and checking if it's actually below 0. I was just like thinking, I guess I was also trying to take into account like you know, maximum, like very large numbers. I wasn't sure about how the input looked. Now, some of these kind of tests, or some of these kind of you know, these exercises has like the testing data is trying to trick you in all kinds of ways. But yeah, I was trying to account for like all kinds of things, but like massive numbers. So that was basically kind of one of the only thing. Maybe, yeah, well, we're doing a mod here, so this shouldn't be a problem here. But if I didn't have the mod here, this could technically like overflow as well, but it never did because n was never higher than like 100. Or 200 or something. 1,000 at least. Yeah. So that's basically what I did here. So like dials always between 0 and 99, and then this would wrap around, and then we would check if this is larger or than 99. Then I did this little mathy thing here to so I had to math this out in order to actually see what I need to do here. So we subtract this in order to restore it to the actual wrapped kind of value where we take like max int. So that's like, you know, if you think about the bits, it's all ones. And then we subtract 99 from that, and then subtract the result from dial and store it there. So that turned out to work there. But I had to math it out because there was like a one-off error. I first had like minus 100. Yeah, so basically when you do the wraparound, it goes to max int. So that was what I was thinking, like, yeah, okay, so if I remove max int, I should go back down, right? And then I just had to figure out, okay, what do I need to also keep in order for it to wrap properly here? Yeah, that your solution is way simpler. I mean, and in a good way. I just tried to be, I guess I tried to be a little cute here. Yeah. All right, let's just do arithmetic real quick here. Actually, this might be pretty hard actually because of the parser and lexer and stuff. So here's basically member assign. Maybe we should have a special thing, which is like we're trying to do a arithmetic expression. if parse arithmetic is it arithmetic? No, it's arithmetic expression, and if we have it, we will return it. So basically we're trying parse maybe, yeah, parse maybe arithmetic expression. Sure, parse maybe arithmetic. Actually, it's a option. So first we expect, hang on, we know that it's an identifier. I mean, it could be a number as well. At this point it's an identifier, but I guess it could be either or. It has to be first or left. Okay, let's pick three things. No. You can see what I'm doing here. This is so stupid. I'm kind of going with what the AI generated, and it's basically you're peeking along the tokens. I don't know, maybe this is a genius way of doing it. I usually use like recursive descent with parser combinators, but this is entirely different from what I'm used to doing here. So basically I'm like, okay, well, we're picking here, so let's check if, so we'll have like the left is the first one, and I just don't know, man. Maybe we'll peek until we deem that the arithmetic expression is ending or something like that. Well, we could build up the as we go along, I guess. We could build up a list. So like components. I'm just gonna make up something here. Arithmetic component. And this could be, I don't know, let's just do union enum identifier, whoops, add operator, or wait, no, operator. Oh, we have this, I guess. Okay. And then a journalist article about Pratt parsing if you end up going that direction. Oh, okay, I've never heard about that. That sounds cool. Welcome to my particle about Pratt parsing. The monad tutorial of syntactic analysis. The number of... Well, I like the word monad in this already. There's a very early usage of the word monad. That's good. Syntactic analysis. The number of Pratt... parsing articles so large that the number of Pratt parsing articles is so large that there exists a survey post. What? The goals of this particular article are raising issues so kind of left recursion problems always parse, yeah. Pratt parsing is one of the most frequently used techniques for handwritten parsing. BNF, yeah. Recursive descent. Yeah, this is kind of what I'm doing here. I feel like maybe yeah. Pratt parsing the general shape. Using lost loops, Pratt parsing uses both loops and recursion. Okay, yeah. Nor does it make... Hello, Metallics. Yeah, that's the... you know, that... yeah, sorry about that. I mean... that you can't look at the examples because none of those features work, and also the syntax is probably gonna change as well. So yeah, if you look at like the latest commit messages, you can see kind of where we're at. I recently implemented mutable variables and closures in functions, so now you can actually mutate, because before you couldn't even assign reassign mutable variables, but now you can. And now I'm trying to implement arithmetic expressions. So okay, well, I mean, this is familiar here, except for the loop. Maybe I would have like, I don't know, I would do like a sequence or something. 1 second. Alright, yeah, I'm not sure about loops though. Precedence. Yeah. Okay, before I do anything here, what I was thinking here is basically we read in a list of arithmetic expressions. This could also be, you know, parentheses and stuff. So it could be an arbitrary expression as well. So let's do that. And what could it be more? I guess, well, I guess that covers everything. I mean, this could also be an expression, I guess, but we want it to be more like, okay, let's say that this is like a parenthesis, and then we would have like a number or something. Like a literal. Makes sense to skip to the end. Okay, let's try. Well, yeah, that just shows that it works. BP. What is this? Rust? Expression. We get. Okay, yeah. Yeah, it's Rust. Yeah, great. All right, we're okay. So we are reading from the Lexer here. We're matching some kind of token here. Operator that. Then we're doing this again on the left-hand side, and we assert that this is that. Otherwise we have some kind of operator. Wait, the first one? The first? I guess this is a unary operator. Prefix binding power, okay. And the right hand side. What is this? Are we making a list or something here? I don't know. Anyway, okay. So first we have this, kind of like the prefix maybe. Or checking it for this trivial thing maybe. And then the parentheses. Okay. And then the unary. And then we have end of file. Wait, what if you have an end of file at the start? That would not work, I guess. Okay, well, maybe we can see here. So, oh, panic. Okay, so either we have an end of file that we break, or we have an operator. I guess this means operator. I'm just guessing here. So basically, okay. So it's kind of doing what I'm doing right now. We're picking, and then we have like, you know, yeah, it's kind of doing the same thing. The algorithm is something like read the smallest node and then extend it while you can, only using operators with at least given priority. Right. Yo. But there we have this like binding power and stuff. All right. Well, let me just see if I can do something with this here. Priority, yeah. I figured, I was just thinking like how it would fit into everything. So my idea is I build up the components as we go, and then we end up with a list of components, and that will be kind of the expression. And then you would have to, like, one idea I had was that you would walk through, you would have build a list of operators that is in this list. So we build a list of operators. Now each operator has a precedence, and so you would sort them by precedence, and then you would first look at the one that has I guess the lowest precedence, and then you would group the components based on that. So let's say you have like, you know, 2 plus 3 plus 4 plus 2. Now this is actually like 3 components here. We have this one, and this one. So this is not really interesting, I guess. But if you have this, okay, let's just do this to simplify it. Now this would have higher precedence, so we would start with looking at this one. So we would separate into groups, where this would be one group and this would be another group, and then you take that the groups together and form, you know, this list of pluses. So you would have like, you would have this plus this, right? So now you have your first kind of expression, and if you have multiple things over here, this would be like this. Now we kind of have a new list, I guess we could say, where each expression is separated by a plus now. So we have a new list, and then you go to the next one. The next operator is the times. So now we would have to kind of like recursively descend here and do the thing like for each one here. So then this one would be, you know, like that, and then this would be. So that was kind of my idea for the algorithm. I'm not sure, but maybe it's super unoptimized. The compiler is kind of messy, but I guess you can read it and understand the algorithm. Right. Well, I'm gonna try doing this here. So, okay. I guess we don't need to peak 3 though. Well, here it's kind of like we can make a snapshot, and then if something goes wrong, like if we don't get an arithmetic expression, we could restore the snapshot. So now we can do next all we want here. Hopefully, if it works. Like, I'm sure if this actually works, the snapshot thing. It should work. It's fine. How would you say algorithm respect to precedence? So basically the operators would have a built-in precedence. So I would kind of define the precedence somehow. Like maybe here you could add like, you know, get precedence, or yeah, precedence binary up, and I don't know, just a number, and then it's like return. I mean, either we could just order that, we could just order them in their precedence, I guess. Because then we could use the integer value of the enum. What does this return? I guess it depends. Let's do like U32 or something. And then, like, you know, this would be stronger, or I mean, wait, should lower be first, or some have the same? I see. Yeah, that's true. But does it matter then? Is the next question. Maybe? Yeah, because if we're grouping, always grouping with plus. Yeah, it doesn't matter, I don't think. I mean, if you have a parenthesis here, that is gonna respect the parenthesis anyway. So if there's a parenthesis here, then let's see. And this is gonna be one. This is gonna be an expression, and then this is gonna be an expression. Yeah, I'm not sure if it matters in this case. I guess we'll find out. Also, not sure what about these, like equal should be at the end. That feels, and less equal, less greater. Wait. Yeah. Times and divide. Maybe. I'll do an integer maths. So like, let's say you do times first, then it would be, or I mean, if times has stronger or lower precedence, then we would group it like this. But is it, I don't actually know what the correct, is the correct way, like math way of doing from left to right? Like if they have the same, you're doing from left to right. I think that is the correct way, but I don't remember. So that's true. Maybe they should have proper. But what you could do, you could just switch, and then we do this. Whoops. I don't know actually how to get this like into a macro where you can do each one, like add one extra each time. Maybe if you take the previous one, actually you start with 1 and then you do like this, add, then we go up and we take that one, go back here, reverse paste, add 1, and then we're done. Hey, except it broke here. All right. So Add, subtract, same. Multiply, divide, remainder. I guess it's the same as well, maybe. Oh. Yeah, that could work two-step actually. But this is, I guess this is more proper. You know, the multiply divide thing, that could actually be, yeah, good. That's a good point there, Kobe man. This one, should and be stronger than or? I would have to look this up here. Greater. So this is not really the same thing. Like these are like kind of like isolated. This is like not even the same thing. I don't think. No, wait, they could be. You could have like equal and then and. Yeah, these should be. Yes. Yeah, it makes sense. Logical operators should have less precedence than add. Yeah, okay. So precedence. Let's just do this. Let's do 10. We're doing basic now. No, you're 20. Should and be stronger than or. Yeah. 1 + 1 = 2, yes. And then you have and, which should be the whole expression and something else. Yeah. So these should be... No, this should be the least... Yeah, the lowest here. And then this should be like... there. I don't know about these one. Like all of these should be the same, right? I'll do like 15. Doesn't matter, you can always change it. It's not like we're storing this in some in the source code or anything. All right. Okay, so and is the most loosey-goosey one. Wait, shouldn't it? No, it should be the other way around. Or should be the most loosey-goosey one, I think. I guess it depends. I could never trust how this is. Most lengths and binds stronger than or. Yeah. Because it's like you want to have a... It's like in Bash. If you have like something that succeeds and something that fails, or handler, error handler. Now if this succeeds and this fails, we run this. But if this, okay, but now it says if it succeeds, but let's flip this around. So this fails and this succeeds. So now this fails, so it goes over here to the handler as well. So the, in essence, it's like this. And that seems logical. That seems correct. All right. And if two, I guess if two operators then have the same precedence, we would do like a left to right. So in that case, this is like example 1. Uh, 2 plus 4 minus 2 plus 3 minus 1. So since they have the same, we would just do like left to right. So basically, this would be like, wait, what does that mean? Yeah, we do this first, and then this, and then this. And then this. Okay, what if we had like now a times in here? So then we would do 2 plus 4 minus 2 times 3 minus 1. It would be like this. And then we would do left. So once we're left with the same precedence, we do a left to right. Okay. I feel like this could probably be a lot like simpler. There's probably a lot more simpler solution here. What's going on here? What this? Oh. Oh. No, we don't need this. Do we? Oh. Okay. Now we have that. That works. Now this one is just to know which ones exist, I guess, so we don't need to go through everything. I guess it doesn't really matter much. Okay, we do peaking. No, let's not do that. Let's do this. And then we'll do like while true. We get the next. Token. Now we do switch on that. Switch on the tag. We can have an identifier. Then components, append. This would be identifier from token. Next. We can have, yeah, a bunch of stuff. equal greater equal less equal what else? Add, no, plus, minus, multiply, times, what is it called? Star, maybe. Division, no. Slash, I guess. We have and or amp, except it's not going to be amp, it's going to be and, actually, because it's sig, kind of. And then we're going to have or. Okay, these are going to be the binary operations. Subtract, multiply, divide, remainder. Not equal. So bang equal. All right. I'll just do the same thing. Does this have a span? No, it doesn't. It should be spanned. Let's do a cheeky move here. Spanned. Let's add from token. And this would return a span t. Then actually not st binary expression. You don't really have a span for the binary operator, I guess. I guess we don't really care about that. Maybe we do, maybe we don't. Well, let's do this anyway because this is kind of interesting. So from token, because it's going to be a little bit of generics here. So what we're going to do is we're going to check if the underlying thing has a function called from token, and if it has, then we return t dot from token token. If it doesn't, it's going to be a compiler error saying, well, actually, you know what, we could just return from token immediately here and just assume that it exists, because this is going to be a compiler error anyway. So yeah, so now we it's kind of forwarding this from token there, except this only gives us a t, so we could return payload is that, and then span is going to be token.span. There we go. So now we can actually call from token here to give us a span binary operator. But yeah, these don't exist. Flow control, literals, keywords, operators, punctuation, amp. Where we maybe okay. The amp. Maybe it will work, except it only works for pipes. And then and or is going to be only for logical, like Boolean operators. I don't really like that though. I don't like mixing it up like that. I'm trying to keep it the syntax like concise and not have too many variations. Yeah, but anyway, I mean it's easily changed, but let's just add these things. Else we're gonna end the thing and take it from there. Yeah, we could also have a parentheses, which means we need to, yeah, then we need to do like components add a expression, parse expression, skip nested structure, no, skip type parse function. Yeah, this part, a primary expression maybe is what we should get here. Identifier. Yeah, maybe we should do a primary expression actually. No. It should only be that if there's a left parenthesis. Also, let's peek instead. If we get here, we consume it. And if we get here, we will try to append an expression, which is parse expression, no, not parse primary. We parse an expression and then we expect a right parentheses. Then we don't actually need to and then we do a continue there, yeah. because we consume the token here instead. Let's make this maybe a little bit more readable. Wait. No, it's like this. Man. Okay. All right. Yeah, okay. Now, okay, let's take care of these issues that we have. So this one, we do a try. Snapshot. Oh yeah. So we need to take care of it. So basically here it's like if components, if we only have like, oh yeah, we need the operators, we need to like validate that the okay, let's do this. Let's do like arithmetic state. And this is an enum, so either we're reading an expression or an operator. And then here we have the state is gonna be arithmetic state dot expression. So first we're reading an expression. So we would need two different ifs here, or switches. Oh my god, what happened? Switch on state. If it's an expression, we will do that. If it's an operator, we will do that. Also, no, not also. Okay, let's do this. There's a lot of nesting going on here, but whatever. So here we want this, or parentheses. And then here we want this. Okay. And let's do like state advance. We'll do switch on self. If we are an expression, self is gonna be an op. If we're an op, we got an expression. So we're always switching there. Okay. So we're toggling between the two states. Each time, each iteration, we have read one expression or one operation, and we're toggling between that. I realized also we could make two different functions that would read the two different things, but whatever. This is how I chose to do it, damn it. Okay, and then yeah, so if we have an expression, we're expecting either identifier or a more advanced thing, or some kind of literal, so like a number, wait, integer literal, float literal, maybe even a string, but we don't really have that. I guess we'll no, strings would be their own thing. Yeah, strings would be like, let's do like string start, string start. That would lead to some kind of error right now. Alright, 1 second here. Okay. Alright, sure. Let's do like, well, let's do like string string in arithmetic expression not allowed or something, I don't know. Very expressive error there. Okay. Else, I guess we do return parse error unexpected token. No, actually, the thing is, we could have advanced through the state. No, we need a terminator as well. That's what we need. If we are in expression mode, we need, no, if we're in operator mode, we could also read a terminator. If we have a terminator, we will break. Except if we're trying to read an operator. Yeah, that will break. Yeah. Otherwise, there should be like an unexpected token or something. And let's see, there we append that. We advance. Yeah. And here, if we're trying to read an expression, we can read an identifier, another expression in parentheses, literals, strings are not allowed. If we're reading anything else, should we return null at this point, or just break maybe? Maybe we're looking for a terminator here, but that doesn't make sense because you can't have like an operator and then a terminator. Yeah, I think we just do unexpected token for now. I will fix it if it's something weird later. So then we have int and floats. I guess we could have bools as well. True. Because we need to work with... I mean, okay, no, because this is arithmetic. Yeah, this is arithmetic, so we're only concerned with that. However, the Boolean logic would basically look the same, except we're looking for different literals and different operators. Also, you could have a mixed expression of Boolean and mathematical stuff. Yeah, so maybe that should be part of it, yes. And then we will just parse everything, and then then we'll do some semantics. Okay. So this would be a literal. So we will append a literal, and then we just do from token next. So let's do like literal. Integer, float, Boolean, and that's it. And then we have a from token. Could we do something like this? Wait, text? What the hell is this? Okay, yeah. I've been thinking. I saw this another time. It's like, yeah, it makes sense in a way, in the sense that you kind of store any kind of number here. You can store a super large number like this, and also a kind of forward handling, like parsing of the number and handling all that through, and it could have different formats, I guess, as well. So it does make sense in a way. Same here. Oh yeah, we have null as well. Wait, should we even have? Yes, we do have. We should have null. I mean, I guess this is also pretty trivial if it's like a from token, because this is gonna be like text is gonna be token like scene, and then span is gonna be token span. That's the same thing. Bool. Bool. Oh yeah, true. It's gonna be a boolean, and that the value is gonna be true. And then we have false. It's gonna be false. Oops. Otherwise, we will. I guess we'll panic or something. I don't know. This shouldn't really happen. Okay. All right, we got int float, true, false. That goes into the literal there. Cool, and then that gets consumed, and we go to the next there. Great. Okay, so now we're reading, like, we're reading identifiers, we're reading parentheses, expressions, we're reading the literals. Strings are not explicitly not allowed, so you would try to append a string to another string. That will be like an error here. And then if this is anything else, because we're expecting an expression and we get like something that's not doesn't fit here, this would be an error. Except maybe if it's like the first one. No, because we know it's an identifier, I guess. Or a number. Like, we wouldn't call this function if we didn't know it might succeed. Maybe. Okay, but then, and then if we're reading an operator, we try to read any of these. And yeah. And we store it in the list. Oh yeah, actually we should, this should be like a hash map actually. Or a set. So like a hash map. Array hash map. Maybe auto hash map. The key type is binary operator. This is void. So now it becomes a set. Alright, and then so this is a set of binary operators. And here we will do operators put and the key is gonna be whatever's in here. So actually the operator is gonna be like spanned operator from token next. So we want that. I guess we could also use components get last operator payload. All right, see, it's like a set, because this value is void, so we don't even need to pass it in. It's kind of overloading here. I don't think we need to pass it in. If we do need to pass it in, what you could do is you could do this. I'm not sure if you need that or not. That's like the only case where Zig actually has like kind of like overloading, or not really overloading, but more like, you know, that you don't have to pass all variables. I'm not or arguments. I'm not sure about that, but I guess we'll find out when we fix the rest of this stuff. But now we have this. We're putting the operator into this set here, because if it already exists, this is just gonna override it. So yeah, you can put in the same place how many you want. And then components item length. So now it's like if the length is 1, right, we don't really have an arithmetic expression. So I think we just abort at that point. If the length is 1, I guess we'll also check like less than or equal to 1. Then we'll return null. We should probably also defer, like delete all this crap here. All right. Now, if we do return null, we also want to restore snapshot as well. There we go. So we undo everything we did and we go back to whatever. Yeah. Now comes the actual, like, the algorithm, because now we have the components. So the components are like alternating operator with like expression. So you have like x number literal, by like add operator, number literal, multiply operator, and so on in this list here. So each of these is one item in the list. Now and now comes the question, like, how do we, man, this is gonna be so much things. Yeah, you know what, I need to sleep, and I do have some articles to read on this. I want to check out the article that you sent me, the simple but powerful Pratt parsing, because that seems to be somewhat what we're doing here, basically, but a little bit different. So yeah, I wanna check that before we do this. I might also want to like modify this a little bit to better serve our purpose if we kind of find another algorithm, because this feels like it could work, but it also feels extremely cumbersome. Like there are some recursiveness going on here, so it might be not that difficult. But there's basically two scenarios. Like you have, if we find out that all the operators are the same precedence, then we do one algorithm. If they're not, then we do another algorithm, and so on. And we have to create these groups. We have to create these expressions. So there are a lot of things going on, and I don't have the brain power right now to to actually implement it. So I'm gonna leave this for now. But yeah, thank you very much for watching. I'll go and sleep now, and you take care.